Okay, 2.4 is on rates of change. This is what was in lesson 1 with the velocity and the distance, and you guys kept asking me if it was going to be on the quiz, and I said it'll come back with a vengeance, and it'll just keep coming back forever. So now it's back again. So physics is all math, 60% math, which is why I love it so much.
But apparently it's
Huh?
Yeah, physics is the most basic. I got that wrong. I got that wrong. I said there's nothing.
Okay. So if you were looking for something to memorize, here it is. Average rate of change. Okay. Average rate of change is the amount of change. So the amount of change in the y-axis divided by the total length or the interval. We've gone over it before. It's basically f of t2 minus f of t1 over t2 minus t1. And this, I can't stress enough, this is average rate of change. This is the same as the slope that you guys are used to from before. It's important for you to remember that not just the formula, but that this is called the average rate of change, because very soon you're going to have another type of rate of change, and it's very common for students to confuse the two. Okay? So, average rate of change is just slope of 2 points, basically. Okay? All right, we're going to be given an f of x and an interval, and we're going to find the average rate of change of the function over the interval. So it's like, 0 and 4, it's like t1 and t2. So what you want to do is the formula, right, like that I put in a blue box over there, it's f of the second number 4 minus f of the first number in the interval 0 all over 4 minus 0. Now, f of 4 means the y value when x equals 4. So I'm going to plug those into this function here. So f of 4 is the square root of 9 minus the square root of f of 0, which is 1, all over 4. So that's 3 minus 1 over 4, which is equal to 1/2. Okay, what have we found? What we found is the average rate of change from 0 to 4. So let's go to f of 0 here and f of 4 here. Those are the 2 points that we were looking at. And if I were to connect those 2 points, all right, that's the slope of the line that connects those 2 points. Okay? Notice when I zoom in, right, that line crosses the graph in 2 places. And in geometry, you learned that when a line crosses a circle in 2 places, it's called a secant line. Remember? Okay, that's what this is called as well. It's a secant. Okay, so that's how you do it. Yeah.
Why those points?
Because those are the points that you were given, 0 and 4. Okay, so let's do another one. Yes, we're going to have some trig functions in there. Okay, so the interval is 0 to pi, so we're going to do f of pi minus f of 0 all over pi minus 0. F of pi, let's just plug it in. Let's take our time. It's 2 plus sine of pi minus 2 plus sine of 0 all over pi. Okay, so here, right here, we get 2 plus, what's sine of pi these days? Not 1. Sine is the y value at pi 0. Here, 2 plus, what's sine of 0? Y value at 0. Also 0. Okay, so 0 degrees or 0 radian and pi radian are here. At those 2 points, the y values or the signs are 0. So 2 plus 0. So what we get is 2 minus 2 over pi. That's 0 over pi, 0. Okay. Let's go to f of 0 on the graph. Let's just see what we've done, right? F of 0, f of pi. Remember what I said before. What we have found is if you draw a line that connects those 2 points, like I did before, that's the slope of that line. And do you see how I got a horizontal line? So the slope has to be 0. Do you see how like harmonious it all is? Yeah? Okay. All right. So, because calculus is a way to basically describe, real life problems, they're not all going to be, just, here's a random function, find the rate of change. You're going to have some actual situations as well, some modeling. So let's take a look at this. The figure below shows the growth of a fruit fly population in a controlled experiment. Compute the average change, the average rate of change, and the slope of the secant line, PQ. So the average rate of change and the slope of the secant line, those are two ways of saying the same thing. Okay? So take a look at what we're given here. We're given this, this graph, and they've highlighted 2 points for us, P and Q. Those 2 lines are connected by that black line. That black line crosses the graph in how many points? 2. It's a secant line, right? Now, if I find the slope of that secant line, it's the same as having found the average rate of change between those 2 points, okay? So that's what we're going to do. We're going to find the average rate of change. One way to say that is delta P over delta T, the change in the y-axis, the vertical axis over the delta T. You've seen that in science. So we're going to go f of 2 minus f of 1. So 340 y2 minus 150 y1 over x2 minus x1, right? Or f of 2 minus f of 1 over t2 minus t1. So it's all the same. So then that will be 190 over 22. You've got to plug it into the calculator. That's about 8.6. Okay? And I do the curvy equal sign because that means approximately. That's just habit. You can write equal. Okay. One thing I was bragging about downstairs is how everybody had the limit notation correct on their quizzes. And so that's like fantastic, because is secant slope any different from the average rate of change? No. So it's just same as above.
So why is it like a trick question?
Yes and no. It's like a, solidifying concept question.
Will it ever not be the same?
Nope. Because look at the next sentence. It says we can always think of average rate of change as the slope of the secant line. Okay? So I saw that coming. Okay. Always. Now, this is fine. This is secant. It crosses the graph at 2 points. All right? A tangent. How many places does a tangent cross the circle? Back in geometry. Nope. Nope.
Zero.
Once. A tangent crosses a circle once at 1 point. It just like brushes by the circle and just touches it at 1 point. Well, it's the same in a function. A tangent to the curve crosses or hits the curve at exactly 1 point. Okay?
What do you mean?
You see how this secant line here crossed the curve at 2 points?
Yeah.
Okay, if we go over here and if I draw another line, like here, that only crosses it at 1 point, that only touches it at 1 point, that's a tangent line. Okay, so average rate of change is basically how much something changes over time. So for example, if you drive, 300 miles, we said this before, and 5 hours, what was your average rate of change? What was your average speed?
3 hours, 500 miles, 3 hours.
300 miles, 60, right? 60 miles an hour. But were you always going at 60.0 miles an hour the whole time? No, that's impossible, right? So if at any given point you happen to look at your speedometer and let's say it read, 67, that would have been the rate of change at that exact point. Okay? So take a look here. The rate at which something is changing at a particular value is the slope of the tangent line. Okay? So slope of the secant line, average rate of change. At a specific time, your speed, that's the slope of the tangent line. Okay? So take a look here. You see this black line over here between 2 points? That's the secant. The slope of the secant line is the average rate of change. But take a look at this red line here. That red line, it only touches the graph at one point. This is a tangent. Okay? And when I find the slope of the tangent line, it tells me the rate of change at that particular instant. Okay? All right. We unfortunately have to stop here, but that's fine.